Hello students, today we will see uh, in microwave radar we will go for the group velocity and phase velocity, and after the completion of group velocity and phase velocity we will go for the cutoff frequency and cutoff wavelength of waveguides. So just remember, the group velocity is velocity of waveguides. So basic definition of group velocity is rate at which wave propagates through a waveguide is known as a group velocity. For example, this is a waveguides. So in this waveguides, this is a rectangular waveguides. So in this waveguide, a wave will be propagated. So the speed of this velocity will be defined as a group velocity. And the basic definition of group velocity is what? The rate of the rate at which wave propagate through the waveguides. So the rate at which wave propagate through waveguides is known as a group velocity. So it will be given by Vg, or it will be denoted by Vg. That should be delta W divided by delta beta. These are the formula for group velocity. Now we will go for the phase velocity. So the Vp stand for the phase velocity. The basic definition of phase velocity with which the wave changes phase in direction parallel to the conducting surface such as a wall of a waveguide is known as a phase velocity. So here the speed or the velocity at which a wave changes phase means, for example, this is a wave, so that will be traveling inside this particular hollow rectangular. So its phase will be changes. For example, it will be like this one. So some sort of phase will be changes with respect to parallel of a conducting surface such as a wall of a waveguides. Means this is a wall, these are the wall of waveguides. So it will be this phase velocity will change with respect to or parallel to the conducting wall of a surface of a waveguide is known as a phase velocity. So phase velocity is given by Vp equal to what? Cos theta. Theta is basically a phase angles. So we will go for the relation of group velocity and phase velocity. So Vg into Vp equal to what? C square. C is basically a velocity in a free space. So the phase velocity is always equal to or greater than the group velocity. So just remember, this phase velocity must be maybe equal or maybe greater than group velocity, and their product will be equal to square of free space propagation velocity. So the multiplication or product of group velocity and phase velocity equal to the square of free space velocity. So c is the velocity of free space. Similarly, if you find out the wavelength of a group velocity, so because phase velocity of a waveguide is greater than velocity in a free space, the wavelength is given frequency will be greater in the waveguide than in free space. So what will be there? This group velocity equal to what? Lambda 0. That is a lambda 0 is basically a free space. Lambda 0 is basically a free space wavelength. So lambda 0 is a free space wavelength. So lambda g equal to lambda 0 into Vp divided by C. Vp is the phase velocity divided by the C. That is a velocity in free space. So today we will see the definition of group velocity. Basically the group velocity is nothing but the rate at which the wave propagate through the waveguide is known as a group velocity. In phase velocity, the velocity at which a wave changes phase in direction parallel to the conducting surface such as a wall of waveguides is known as a phase velocity. So Vg equal to delta W divided by delta B, phase velocity equal to cos theta, product of group velocity and phase velocity equal to c square, that is velocity of free space. Similarly, the wavelength of a group velocity equal to lambda 0 into Vp divided by c. Lambda 0 is the free space wavelength, Vp is the phase velocity divided by c. The c is the velocity of a free space. Okay, thank you.